we'll go to exercise 2.2, question number 2. What is given in the question? Find the quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. That means 1/4 and -1 both are given. That means sum of zeros is equal to 1/4. Product of zeros is equal to -1. So you know what is the general form of a quadratic polynomial px is equal to x square plus bx plus c. A is not equal to 0, a, b, c element of real numbers. Okay. Now we know if alpha and beta are two zeros of the quadratic polynomial, then sum of zeros, then alpha plus beta is equal to minus b by a. Alpha plus beta is sum of zeros is equal to how much? 1/4. That implies minus b is equal to 1 and a is equal to 4. That implies b is equal to -1 and a is equal to 4. Now you got a and b. Now we find out c. Alpha beta is equal to c by a is equal to -1. So this is alpha beta is product of zeros. So that implies c by c is equal to minus a. C is equal to minus a. So that implies c is equal to -4 because a is equal to 4. Already we got it. Now we have a, b, c. So we have to frame the polynomial by using the value of a, b, c. Now you got a, b, c, x square plus bx plus c. So a is your 4x square plus b is your how much? -1 into x plus c is your -1. So this is your is equal to 4x square minus x minus 4. The required quadratic polynomial whose sum of zeros is 1/4 and product of zeros is -1. So here we got what? 4x square minus x minus 4. Now we will do it alternatively. We will apply another method to solve this. The sum and the product of zeros are given. Now alternative method. So now sum of zeros given. That means alpha plus beta is equal to 1/4, alpha beta is equal to -1. Already I have told you alpha and beta are two zeros of the given quadratic polynomial. We have taken it, we have assumed it. So now the quadratic polynomial is equal to k into x square minus alpha plus beta into x plus alpha beta. We know it, that is equal to k into x square minus 1 by 4 x plus minus 1, that is equal to k x square minus x by 4 minus 1, that is equal to k 4x square minus x minus 4 whole divided by 4, that is equal to k by 4 into 4x square minus x minus 4, that I can write is equal to k1. Let's say 4x square minus x minus 4. K is a real number. K is a real number. So k is a real number. K is a constant. K is a constant. K constant. Constant. So when k by 4 I have taken k1, that is also a constant. So what is the required polynomial? We are getting 4x square. So the quadratic polynomial is 4x square minus x minus 4 whose sum of zeros is 1 by 4 and product of zeros is minus 1. This is alternative method. Note it down. Note it down. This alternative method I have done it by using the formula. So now we can also do it in another way. So let's try the third method. Now another alternate method. Alternate method. So we know that sum of zeros. So now our general form x square plus bx plus c. Let a is equal to k. So we know sum of zeros is equal to minus b by a is equal to 1 by 4. Okay. So minus b by k value a is equal to k is equal to 1 by 4. That implies your k is equal to minus 4b. That implies b is equal to minus k by 4. Okay. Now sum of zeros. Now product of zeros. Product of zeros is equal to minus 1. So product of zeros is what? C by A is equal to minus 1. That implies C by K is equal to minus 1. That implies C is equal to minus K. Now putting the value of ABC, putting the value of A, B and C, we will get what? We'll get in ABC in ax square plus bx plus c. We will get. Where we'll put? In ax square plus bx plus c. Now a is kx square plus b is how much? Minus k by 4 into x plus c is how much? Minus 1. Minus 1. That is equal to how much? Kx square minus kx by 4 minus C is your minus k. C is your minus k. C is your minus k. That is equal to minus k. K common, x square minus x by 4 minus 1. That is equal to k into x square, directly 4x square minus x minus 4 by 4. Taking LCM, that is equal to k by 4 into 4x square minus x minus 4. K is a real number. So, k is a constant. Hence, k by 4 is also constant. Therefore, the required quadratic polynomial is 4x square minus x minus 4, whose sum of the zeros is 1 by 4 and product of the zeros is how much? That is minus 1. By putting different values of k, we will get different quadratic polynomials. Mind it. By putting different values of k, we will get different quadratic polynomials, and that polynomials will have the same sum of zeros 1 by 4 and product of zeros minus 1. So move on to the bit double I.